Good afternoon. We're Quick Lane Tire and Auto Center. I'm Crystal Tobias.
I'm Raisa Cisneros.
And I'm Jose Verastegui.
Auto centers are an essential part of auto care for those who are not mechanically inclined. However, despite the quality work of the auto center, it still takes time to repair and maintain every vehicle that comes in, especially when there are multiple customers throughout the day. For a customer who is waiting for their vehicle to be taken care of, with multiple customers ahead of them, they are given the option of leaving their vehicle there and picking it up later. Unfortunately, sometimes it takes an undetermined amount of time for a vehicle to be ready, and it might take some time after that for the mechanic to find the time to call the customer to pick up their vehicle.
Our proposal is to make an application that tracks progress of the vehicle's repair, therefore increasing the communication between the mechanic and the customer and also shortening the wait time. System capabilities. The application should be able to collect the customer's contact and vehicle information, provide the customer with information as to when their vehicle has been taken in to repair, what state of repair it's in, when the vehicle is ready for pickup, and when the mechanic is finished. It should also be able to send this information to a mobile device and to store the customer's information for future repairs. The benefits of this application include increased communication between the mechanic and the customer. It will shorten time wait, and it will also speed production and increase customer loyalty. So what their system consists of right now is that the customer takes in the vehicle, the mechanic prepares the vehicle for repair, records and notifies the customer, and the customer then checks for updates. The mechanic repairs the vehicle, then records and notifies the customer. The customer then picks up the vehicle and makes a payment. This is all done in person, which is time consuming for both parties. Use case description. The mechanic asks the customer for their information and inputs it into the system. The customer then enters the telephone number into the system, and the system then shows the current status of the customer's vehicle. The customer then clicks a part of the service of the drop-down menu to check the status. The mechanic then accepts the customer's vehicle into the system using the customer's telephone number and updates the system every time an area of the vehicle is complete. Then updates the status as complete, notifying the customer the vehicle is ready to be picked up and the amount payment is due.
Thank you, Riza. Okay, next up we have a detailed use case description. More specifically, we have a fully developed use case description for the View Automobile Status use case to help us gather a deeper understanding of the user's needs. When a customer wants to view the status of their vehicle, it will trigger this event. The brief description is the same as Riza mentioned earlier. Our actor is solely the customer. Parties interested include the accounting and mechanic departments. The preconditions needed to be completed before the use case can execute include the customer count and mechanic subsystem being available and the customer existing. The postconditions are the vehicle must be accepted, the vehicle status must be shown, and the wait time must be shown. On the flow of activities, we have the steps performed by the actor and the responses required by the system. The exception conditions that will hinder the View Automobile Status use case are the customer not existing, the phone number being incorrect, the vehicle information being incorrect, or the vehicle not being in the garage. Here we have an activity diagram that documents the flow for the View Automobile Status use case. We have a customer and a mechanic system swim lane. The customer has 3 activities, and the mechanic has 5. The customer requests the vehicle status, in which the system responds to by asking for information including the customer's phone number and vehicle information. Once the customer inputs that information into the system, it then locates it, which leads to the customer verifying it. The system then notifies if the vehicle has been accepted, shows the status, and the wait time if there is any. Okay, now our system sequence diagram is going to help us understand the flow of information into and out of the system. Here, our customer is interacting with the mechanic system and wants to check on the status of their vehicle. The customer will have to supply information included in the parentheses, which is their phone number, their VIN number, and the license plate number. The system responds with a detailed account of the user's information, including the customer ID, the name, phone number, VIN number, license plate number, the make, model, and year of the car. The customer then specifies if the information is correct. If the information is correct, it shows the status and/or the wait time if there is any involved.
Okay, this is the workflow between the mechanic and customer. We start off with the customer dropping off the vehicle. The mechanic makes sure that their information is in the system and the work order is placed. If the vehicle has been taken in, it displays it on the program. If the work has begun, it displays the work is in progress. If the work is completed, it moves on to final inspection. And once the inspection is complete, the vehicle ready status has been displayed, notifying the customer, which moves on to the customer payment, which ends the system. This is a working prototype of our tracker. Below, the customer ID can be typed in. As each phase is completed, the status changes, letting the customer know the state that their vehicle is in at the moment, all the way up to the completion of the repair. That concludes our presentation. Thank you very much.